3D printers, CNC mills and lathes, or laser cutters are all examples of computer numeric control, or CNC machines. They are all based on a machine controller reading an instruction file which describes the movement and operation of the machine tools as they add or subtract material during manufacturing. Most CNC machines share the same coding language used to describe that instruction file. These are G-codes. G-codes are a text-based programming language which describes the sequence of movements and event instructions for a machine. These instructions are executed in sequence, line by line, by the controller of the machine. Each line will define a type of operation to be completed and the parameters for that operation. For example, the speed of movement or temperature of a nozzle. While these files can look complex, they are mainly a long list of very simple instructions that can be interpreted by both machines and humans. This is a sample of a G-code file that includes the instructions for machining a simple part on a CNC router. It includes some basic information which is used to set up the machine and define the coordinate system, and is followed by 3 machining operations. The first machining operation uses an end mill to cut out 2 holes. The G-code defines the tool type and the RPM to be used and the motion used to achieve the cut. The motion G-codes, shown here, all have the same structure. Firstly, a G-code command declaring the type of motion which is defined by a number. In this section of code, G0 is a linear rapid motion. G1 is a linear motion with a specified speed in millimeters per minute, defined by the F value. And finally, the G3 is an arc motion. Next, each command has a coordinate value, defining their motion using X, Y, and Z values for linear motions, or with the addition of an extra I and J value, which are used to define the motion in an arc as called for in the G3 command. If a position is not listed in the G-code, it's assumed to have not moved along that axis. This can be seen in the first G0 command, where the motion applies only in X and Y. And with this machine, the lines without a new G-code command will continue with the previous one. In this case, the next movement will also be a G0, or rapid move, down to a Z position of Z18, but maintaining its current X and Y position. For the G1 command, the speed of motion is set to 400 millimeters per minute, and that motion is only downwards in the Z direction. This speed of 400 millimeters per minute remains until another F command is given 2 lines later. Finally, the G3, or arc command, tells the machine to move through an arc defined by points in X and Y, along with the additional I and J values describing the arc radius. The code executes sequentially until it reaches the end of the operation. The second operation is a profile cut around the outside of the part and uses linear motions described by G1s and arc motions described by G2 and G3 commands. The final operation in this file is a drilling operation. This is where we can see some of the other types of code, M-codes, which are used alongside G-codes. M-codes tell the machine to carry out miscellaneous functions. For example, the M3 command starts the tool spinning and the M5 command stops it. M30 is used at the end of the whole program to define the end. A basic understanding of G-codes can help you to solve issues in the use of digital manufacturing, and the ability to edit these files can create a potential for creative uses of digital manufacturing tools like CNC machines and 3D printers.